Imagine playing a game of Jenga where each block represents blocks of carbon dioxide. Adding more CO2 blocks to the atmosphere makes the structure incredibly unstable, resulting in climate change. But how does just 0.0% of this molecule cause this? To understand how CO2 traps heat, let's dive into quantum physics, more specifically quantum harmonic oscillators. Imagine a molecule as a ball and spring model. When disturbed, it oscillates, creating both potential and kinetic energy. In molecular terms, this causes a molecule to vibrate. These vibrations can sometimes create a dipole moment in a molecule, altering the molecule's charge distribution. In CO2, asymmetric stretching and bending motions create a dipole moment. This dipole moment allows CO2 to absorb infrared radiation. When CO2 absorbs an infrared photon that matches its vibrational level, it transfers to a higher energy state, producing heat. So more CO2 is equal to more heat. But you might be thinking, if excess CO2 is that dangerous, then why can't we just capture it? Well, because we know that CO2's unique vibrational modes let it capture heat effectively, but instead of trapping a set amount of heat, CO2 actually acts as a heat conductor, consistently taking in heat and transferring it to other molecules around it, making it difficult to get rid of. Now this is where nanotechnology comes in. Imagine nanoparticles as magnets designed to latch onto CO2 molecules. These tiny particles can capture CO2 even when it's present in very low concentration, effectively filtering it out of the air. Nanotechnology can be used in various forms. For example, in power plant filters, industrial process membranes, and coatings on buildings and vehicles to capture CO2 at the source. In its lifetime of over 400 years, this single CO2 molecule will produce about 5.05 times 10 to the power of 16 joules of energy. This is equivalent to charging your iPhone over 4 trillion times. With nanotechnology, we can help manage and capture carbon dioxide, helping to ensure for a sustainable future for generations to come.